Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Keam Prep, we're going to be looking at some questions of physics which were asked in Keam 2019. So Keam is an exam that deals with the admissions for engineering, medicine, as well as architecture in the state of Kerala. So, passing this exam is an important prerequisite for attending courses. So in order to prepare for these exams in the last minute, it is best to look at previous year questions and how to solve them. And that's what we're going to do today. Here comes our first question for physics. An electron placed in an electric field experiences a force F of 1 Newton. What are the magnitude and direction of the electric field E at the point where the electron is located? We're given the charge of an electron as 1.6 into 10 raised to minus 19 coulombs. Well, let's just consider the charge to be E and the force F is of 1 Newton. Now, electrostatic force, which is the force that's present in this question, is related to electric field by the formula F equals Q times E. So therefore, you'll get electric field as equal to F divided by Q. Here, F is 1 Newton, and the charge is the charge of an electron, which we can represent as E. So 1 by E Newton per coulomb is the magnitude of our electric field. So as you can see, options A, B, C, D all contain the same magnitude. Option E, E newtons per coulomb, is incorrect. Now, we also need to find out the direction of the electric field E. So, how do we find out the direction? Well, normally the electric field E moves from higher potential to lower potential, which is another way of saying positive to negative. However, the force on an electron is from negative to positive. The reason being that electron is negatively charged, so therefore it is more attracted towards the positive side. So therefore, if E goes to the right, then the direction of F is quite opposite. So F and E are against each other. So therefore, option B is the correct option. Now we notice that over here options B and D mean the same. So therefore, we have to take both of them as correct. Now normally this does not occur. This is actually an error that is part of the question paper. So that means that options B and D both are correct. So they will mark both of them as correct answers. So for this question, F equals QE, E equals F by Q, that is 1 by E, and the direction is against each other because of the charge on that electron. So options B and D are the correct answers. Next question. The distance between two charges, Q1 equals 2 microcoulombs and Q2 equals 8 microcoulombs, is 15 centimeters. Calculate the distance from the charge Q1 to the points on the line segment joining the two charges where the electric field is 0. Now, electric field is can be due to a charge that is present in the vicinity. So therefore, when the electric field due to the charges present is 0, that means we have opposite electric fields canceling each other out at a point, say X. So let's say we have 2 microcoulombs here, and then 15 centimeters away, we have 8 microcoulombs of charge. So let's take an arbitrary point as X, and it's at a distance of X centimeters from 2 microcoulombs, that is, Q1. So now we need to find out the location of this point, given that at this point E equals 0. Now, how do we calculate electric field? We know that force equals K Q1 Q2 divided by R squared. And for the same charge, it'll be KQ squared by R squared. Now, since electric field is F by Q, let's suppose over here it's Q1. So that means it'll be KQ divided by R squared. So the formula for electric field is KQ by R squared. Now, at R equals X, the point X centimeters, the electric field E equals 0. That means K times Q1 divided by X squared minus K times Q2 divided by 15 minus X the whole squared equals 0. Now, from this relation, we can write K times Q1, that's 2 microcoulombs, divided by X squared equals K times 8 microcoulombs divided by 15 minus X the whole squared. So you can cancel out K, 2 goes into 8 4 times, and microcoulomb is 10 raised to minus 6 coulombs. So you can take 10 raised to minus 6 out from both sides. So basically what we have is 1 by X squared as equal to 4 divided by 15 minus X the whole squared. Therefore, what you get is 4x squared equal to 15 squared plus x squared minus 2 times 15 times x. So it'll be equal to x squared minus 30x plus 225. And the left-hand side will be 4x squared. So let's take the x squared on the right-hand side towards the left-hand side. So that's 4 minus 1x squared. So 3x squared will be equal to 225 minus 30x. Now we're going to take the right-hand side completely over to the left-hand side. So 3x squared plus 30x minus 225 equals 0. Now, let's see if we can divide 225 with 3. So 7 times 3 is 21, so you get 1, and then 3 times 5 is 15. So therefore, 225 is 75 times 3. So, if we can remove 3, we will get x squared plus 10x minus 75 as equal to 0. X squared minus 10x, plus 10x minus 75 equals 0. Now, we have to split the middle term and in such a way that their sum is 10 and their product is minus 75. Well, 75 has various, factors, but we can use 15 times 5 in this particular scenario. So x squared plus 15x minus 5x minus 75 equals 0. That means x plus 15 times x minus 5. This is after splitting the middle term. That is equal to 0, which means x can be equal to minus 15 or x can be equal to 5. Now, since the distance between two objects is not negative, the value of x is 5 centimeters. So 5 centimeters is the correct value for the distance of the point from 2 microcoulombs at which the electric field equals 0. So therefore 5 microcoulombs is the answer, which means option E is the correct option for this question. Let's look at the final question of this episode. 4 point charges with equal magnitude of charge of 5 coulombs but with different signs are placed at 4 corners of a square of side 10 meters. Assuming that the square is centered at the origin and the configuration of the charges are as given in the figure, the potential and the magnitude of electric field at the origin respectively are. So we have this particular diagram. The sides of the square are 10 meters each, and the origin and the center of the square is at the point 0, 0, so it is the origin. So how do we solve this question? Well, we need to find the potential, the electric potential, that is equal to KQ by R. We also need to find the magnitude of electric field, which is KQ by R squared. So these are the two things we need to find. Now we know that the side A equals 10 meters. The diagonal D is always equal to A times root 2, which is 10 root 2. And half times the diagonal is the distance between the origin and the vertex. So that is equal to 10 root 2 divided by 2, which is equal to 5 root 2. So using the superposition principle, basically the superposition principle states that the net quantity of electric potential or the magnitude of electric field at a point is actually equal to the sum of all the electric fields passing through it. So V net can be written as K times plus 5 divided by 5 root 2 because we're starting over from here. So this is A, this is B, this is C, this is D. So we're starting from A, moving towards B, then C, and then finally D. Plus K times, at B it's minus 5 divided by 5 root 2, plus K times at C it's again minus 5 divided by 5 root 2, and then at D it's plus 5 divided by 5 root 2. Now, what can we do? We can write 5k divided by 5 root 2 minus 5k divided by 5 root 2 minus 5k divided by 5 root 2 plus 5k divided by 5 root 2. So as you can see, there is two positive 5k by 5 root 2's, and there are two negative 5k by 5 root 2's. Both of them cancel each other out, and the effective potential, the net potential here is 0 volts. So V net is equal to 0 volts. Now what about electric field? The net electric field is K times plus 5 divided by 5 root 2 squared plus K times minus 5 divided by 5 root 2 squared plus K times minus 5 divided by 5 root 2 squared plus K times plus 5 divided by 5 root 2 squared. So what we can do is we can take K and 5 root 2 squared, that is 50, common, and you'll get 5 minus 5 minus 5 plus 5. So it's basically 10 minus 10, so that is equal to 0. So the net electric field in that square is 0, and the net potential at the center of that square is also 0. So therefore, the correct answer is option A, 0 volts and 0 volts per meter. Volts is the unit for electric potential, and volts per meter is the unit for electric field. So that concludes this episode of Keam Prep. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. If you want to access more of our Keam playlist, then don't forget to hit the playlists link present in the description box. If you want to, give your opinion about our lessons, then don't forget to use the comment section down below. For getting our latest updates, please don't forget to press the bell icon present below the video. So until the next episode, take care, stay safe, bye-bye for now.